Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments. For tonight, we'll take a look at using TI-Nspire CX Navigator technology to explore topics in biology, chemistry, and physics. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to my students. I'm very happy to introduce our two panelists tonight, Mike Smito and Todd Morstein. Mike Smito is an 8th grade science teacher at Heritage Middle School in Deltona, Florida, and has been teaching for 8 years. He is the science department chair at his school and teaches a variety of levels, including co-taught, AVID, Gen Ed, Advanced, and Gifted Science. Along with teaching, Mike is also the district contact for Science Olympiad and is involved with numerous other district and national activities, including SOFIA, curriculum mapping, STEM integration, and assessment writing. Mike was also named the Volusia County Schools PRISM Science Teacher of the Year for the 2012 school year. Thanks for being with us, Mike.
And Mike, thanks for having me. I really appreciate being here.
And Todd has taught a wide range of science, mathematics, and technology classes for nearly 20 years. He has used TI technology in all of his classes and has helped create TI workshops in multiple math and science subjects. Thanks for joining us, Todd.
Thanks, Mike. It's an honor to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Mike or Todd using the Q&A window. We'll also be using the chat window to send general messages. Once we move to the teacher software and the navigator software, that right section of your screen will be replaced with a green floating toolbar. As a reminder, you can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with some of these activities tonight with your handheld or software, and we really hope you will, we recommend doing this with the recording. That way you can download the activities, download the recording, and then pause and rewind the recording as necessary. We don't expect you to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Mike is going to discuss our agenda.
And once again, good evening, everybody. Thanks for spending your Tuesday night with us here. We have a couple things that we are going to look at today. Among those are a couple different activities that you can use in your classrooms across biology, chemistry, and physics. Those files are going to be tracks of a killer. We're going to look at a specific heat lab. And we are also going to utilize the force probe as well and look at an experiment that we can do with that probe. We'll also take a moment and we will go over some free online resources that you can utilize in your classroom.
Thanks, Mike. And Todd is going to discuss our expected outcomes.
Some of the expected outcomes for this is we're going to look at data aggregation is kind of going to be the one of the central ideas tonight. We're going to look at data from the entire class and what do we do with that data and how do we analyze it. And we're going to look at some other tools on analyzing data, as well as there's been some questions about how to manage graphs and data that we'll touch on throughout the webinar.
Thanks so much, Todd. Mike, it is all yours.
All right. Well, like I said earlier, we're going to start off with our first activity, and this is Forensics with TI-Nspire Technology. First one we're going to look at is Case File 1, and this activity is called Tracks of a Killer. Now, all of these activities can be found on the Science Nspired website, and we'll look later on how to find those activities. But as Todd was mentioning earlier, one of the main things we want to look at is data aggregation. And one of the great things about TI-Nspire Navigator is that we are able to communicate with a variety of handhelds and collect data from multiple students in the classroom, every student in the classroom, and then send that data to all of the students in class. So they have access to all of the data all at the same time. So all of the students will get multiple data sets. This activity it's a forensics focus, and what the students are going to do is they have these footprints that have been pre-set up in the classroom. So in advance, the teacher will have a series of footprints, and these prints are between 0.25 and 3 meters long, as identified in the picture. And the heel-to-heel stride length is around 0.64 to 0.65 meters. From that information, the students are going to have a couple different suspects and try to figure out who the guilty perpetrator is. In order to do that, there's a couple different measurements that each student in the class is going to have to make, because we want to get a series of multiple data points. Among the first measurement that you're going to need, and the great thing about this is you don't need a lot of materials for this activity. You simply need a meter stick and a ruler for your students to work on this. The measuring device that they're going to first measure is the length of their shoe. So we're going to remove their right shoe, they're going to turn it over, and they're going to measure the distance from the tip of the toe to the heel, to the nearest centimeter. They're also going to measure the stride length. So they're going to mark a starting line. They're going to have each person stand on the back of his or her heels. They're going to take 10 normal walking steps, and they're going to get a total measurement of those 10 steps. And they'll divide by 10. This will give them an average of each stride. And I think I skipped the first one here. They're going to measure also each person's height. So each student in your classroom will have a total of 3 data measurements. Each student will then input their information into the evidence record here. Now, one thing that's great about the Nspire is I can send a question out to the students, have them enter all of their data in, collect all of their data, and then redistribute it. Currently, I am running the TI-Nspire Navigator System, and I'd like to show you actually in real time here how we can go about doing that. So let's say I'm a student in class and I'm recording my initial height, and let's say my height is 50 centimeters. I can put a numeric number there for my information. Let's say my shoe length is around 25 centimeters, and let's say my average stride length is around 75 centimeters. Each student will have their data, or each group will have their data recorded here. What I'm going to want to do is I'm going to send out a document to the students. So I'm going to start a new document here on my teacher computer. And I am going to insert a question. Now, this can be done in advance before your students come in, but for the purpose of sharing here, I wanted to show you how this can be done. You have a couple different question types. For aggregating and sharing data, one way of doing this is to create a list question, and that's right here, about 3/4 of the way down. And I'm going to insert this. Now, you'll notice I have list 1 for column 1, list 2 for column 2. The only thing is I had 3 different columns. I had the height of the person, I had their shoe length, and I had their stride length. So I'm going to go over here to my Documents toolbox, and I'm going to click on this Document Tools icon on the top left corner of the screen. If you scroll down and look on the left-hand side here, you have number of lists. Since I have 3 different things that the students are measuring, I'm going to change this to 3. In the top part, I can tell the kids what I want them to do. So I will have them put record record data in centimeters. Now the first thing I wanted them to measure was their height. The second thing I wanted them to measure was their shoe size. And the last thing I wanted them to measure was their stride. Then I would send this file out to the students. To do that, I would do it as a quick poll. And I'm going to start the poll here, and I think I spelled height wrong. We're going to start the poll. Now you'll notice a series of quick polls appeared. And on the student handheld, they're going to see this information. If I scroll down on the left-hand side, you'll see I have student data. And I'm going to click on that. Now on my student calculators, I'm going to start typing in some numbers. And so let's say the first person says they have a height of 55. As I'm typing this in, this is happening in real time. Let's say their shoe length was 25 and their stride length was 74. Student 1 was entering that in. And I'm going to do the same thing for students 2 and for students 3. I have 3 different handhelds here that I'm inputting information into. And you can see as I'm entering this information into the handhelds, it's recording it on the Navigator screen. I now have all of this data viewable on my screen. And if you have a class of 25 kids, you're going to have 25 different pieces of information here viewable. From here, I can now right-click. Yeah, short. I'm going to right-click on this, and I'm going to send the table to a new document. When I do that, it's going to input all of the information into a list and spreadsheet here for me. From this point, you'll have all of this data filled in for all of your students. From this point, I saw someone made a comment, short kids. I do teach 8th grade, so I can see they are a little bit short there, and they can't spell either. But anyway, we're going to send that document out to the class. To do that, there's a little button right up here, Send to Class. And I'm going to click that Send to Class, and it's going to send this file to everybody there. Now, every single student in the class has everyone's data viewable for them, able to work with, and now they can manipulate it. So instead of having just your data to work with, one of the great solutions that TI-Nspire and Science Nspired provides is being able to share multiple data points and use that data, and then you can do a lot with that information. So let's say I'm a student and I have this data. What can I do with it now? I'm going to, from my calculator screen, this over here, another great feature of Navigators on the left-hand side, this teacher software, I can show the keystrokes up here as well. So I'm going to add a page. I'm going to hit the Control and the Dock button. And let's look at data and statistics, because I want to try to put this into a little bit of a graph and see if there's some sort of relationship. So I can look at the different variables. I can look at height versus stride. I can look at height versus shoe size. And I know there's only 3 points up there right now, but having a class filled with 25 students and having 25 different data points, all viewable, and the students taking ownership of that data is a really powerful tool. And it's a great tool alone with this relationship to see if there's any outliers. And then you can have that discussion with your students to see if there was an error where that error may have resulted from. So students can work within this document that I sent them as they go through and work on the file. Within this file, there are also a bunch of other questions for them to analyze. So they'll go through this case file and they'll answer a multitude of questions. So should a linear model be used? We have the students look at R values. We have them look at the relationship between student height and shoe length. We have them look at the relationship between height and stride length as well. And it's up to the students, once they get the proper relationship, to try to figure out who caused the crime. It really is a great activity, especially being an 8th grade teacher. It's a great introductory activity to measurement, data collection, and I can even see my math teachers, when you're teaching slope, because it is a linear relationship, it's a great way to start discussion of slope in the math classroom as well, especially when you get the multiple data points. I could really see Algebra 1 students as well, even working, really liking this. So to analyze this line, now you'll notice this is not really looking like a great linear relationship here. This wasn't actual data. I kind of made those numbers up on the fly. But if I wanted to analyze this relationship, I have this button down here, the menu button. It's the 3rd button down the right hand of your calculator or your handheld. And I'm going to click on that, and then I'm going to click Analyze. And I have a regression, and I can show linear. And this is going to give me my slope. So it's a great way of talking about relationships with linear relationships. It's a great way of collecting data, analyzing data. Todd, do you have anything you'd like to add into this that I may be missing?
No, I think you're doing a great job. I think some people have noticed that, you were talking about the 8th graders, but I think it's a great activity as we go into high school. Somebody said it's a great math activity, so I threw out there, most of our science data is great math data. It's just a matter of finding the right models to work from.
Yeah, definitely. I mean, Algebra 1, it's a great review for your students, and even just giving them something tactile, something they can work with, something that they can take ownership over when you're working on an activity. And the crime scene part too, the students really seem to get into that quite a bit. And again, the data is off a little bit because I just kind of made the data up on the fly. But it really does end up working out really well. I remember having discussion with an Algebra 1 group class one time where we had this, it seemed like this perfect, almost perfect linear relationship, and then we looked at the data and we saw we had someone who was 7 centimeters tall in the classroom. So it was that great opportunity to talk about, looking at this series of data, where may have an error occurred, and how did we get that error as well.
Hey, Mike, and then Renee asked a question. She said, where's the stride length? And I'll let you answer that. Okay.
So I could actually click, if you notice right here, I know I'm only looking at shoe versus height, but if I go over here to the y-axis, notice how I scroll my mouse over here, shoe becomes boxed. And that's a great question, if I click on that, you'll notice I have all of these different options here, and I can click on stride, and then I can change the variables that way. Another great shortcut to doing this on your handheld, if I hit the tab key, you'll notice when I click tab, it automatically switches between the X and the Y axis. So I can set the X and the Y axis to anything that I want to set them to within my set variables. And those 3 things all came from the initial 3 ABC that I sent out here. And Renee, thank you for that question.
Yeah, one of the things that I've noticed as I've done activities like this is that 8th graders will have a size 14 shoe and be 4'11". And when you get to high school and the upperclassmen, that linearizes very well if you've played with these type of models.
Oh, definitely. Definitely.
Hey, Mike.
Yes.
So we had 2 additional questions. One was from Stacy. She asked how you use this activity with your students. So is it, you just walk around where they're sort of going through the activity? Is it more student directed, or how do you use this activity with your students?
Okay, with my students, one thing I've done in the past that works really well is I'll have a sample crime scene set up in the middle of the classroom. I'll have a little aisle where I'll have a series of footprints that I've already made. and I'll have the students go up and they'll measure the actual footprints, the stride length, and they'll measure the shoe size on the actual setup there. From there, I give them the file, and they initially work within groups of 4, and I'll have a ruler and a meter stick at each table. I'll send the file out, and within that file, the file I'm talking about is this one, the one that's on Science Nspired. They'll initially fill out this information within their group. And I'll have them, make some hypotheses and discuss within their group to see if there's any patterns that they initially notice. After they've gone through and they've looked at just their group and the data they got from their group, I'll send the quick poll question out, which I did earlier, which I demonstrated earlier when I went to File, New Document, and then I inserted the question, which was a list. And then I send this out, and every single student enters their information in, and then we display the information up on the screen, and I send it out, and I have them play with the data a little bit and see if they can determine the relationship. And then we have a class discussion about it. So actually, this lesson takes from start to end. It's about a 45-minute, about a one-day activity. So I hope that answers the question. And next, did you say there was another one?
Yeah, we have one more from Ricardo, and maybe this might be good for the whole group to try and think about, maybe respond to. And Ricardo's question was, how can we use this scenario to promote higher thinking skills like making predictions?
Okay, that's great. Should I leave it up to the group for a moment, and then we want me to dive right into that?
Let's leave it up to the group. Let's see what they think, and maybe we'll come back to it.
All right.
Thanks, Mike.
Yep. Hey, Todd, do you want me to pass the ball over to you, and then we can come back to that question? Or
you can pass the ball as people, and as we're passing the ball, it'd be great if you guys can go on the chat window and start adding some things there, and we will be glad to see what we can do to answer those questions as we go forward. So when Mike gives me the ball, and he just did, we're going to look at specific heat now. Okay, so I'm hoping everybody can see my specific heat activity. This is a typical activity that I would do in chemistry. You can do it in other places as well. But specific heat is looking at temperature of, it's doing calorimetry, and I usually use it as an introduction to calorimetry. There's a couple things we're going to do through this activity. One, I want to introduce you to some probes and talk a little bit about the data collection application that's actually built into this. And then I also want to show you again the data aggregation, because as we work with certain sets of data, and this can be in any of your classes, when do we want to bring large numbers into our class and compare them to look for averages, or even look at standard deviations, whatever it might be. All right, so Leslie just said, I'm in calorimetry now. All right, so what we're going to try to do is this specific heat activity, we're looking at copper. I happen to have a number of samples of copper that I've gotten from a supply company, and all of the copper samples are the same mass. And so it makes it kind of nice, because now we can compare these masses. And so as we start out, you notice I brought in an image into my document to show a simple calorimetry setup. And I really like to let the students explore. And I figure that students, especially in science, the first time around, they typically fail the activity, modify the activity, come back and become successful, and they learn a lot from that. And so I'm going to actually, in this activity, I'm going to give you more than I typically give my students. But and you guys can ask questions about that as we go. So we have an image of what's going on. Basically, the main statement of what we're going to try to accomplish here. And at this point, I have a question, and there's a couple ways I can ask this question. One, I can have it embedded in the student's document and they just answer it as they go through it. Or it's really nice to actually send out a quick poll like Mike did earlier. He sent out a list as a quick poll, but we can send out this particular sheet as a quick poll, and the students would get that, respond to it, and then we'd have some discussion time so that they all kind of were on the same page and we knew, the students knew what they are hunting for. And all the answers, if you notice in this particular one, are the correct answer. They need them all. And so we'll move forward and look at some other things. So a set of directions on how they do this, and then we get to the data app. And currently, I have a temperature probe plugged into the handheld, or plugged into my computer right now, actually, through what's called a Go link or an Easy link. There's also the data cradles. But you'll notice it's reading the temperature over here. If I want to change that to Fahrenheit or Kelvin, the great thing about this screen, it is click sensitive. Wherever you want to change something, you click on it. So if you notice where Celsius is, I go over and click. I can change this to Celsius, Fahrenheit, or Kelvin. I can display different decimals. And this many times is dependent on what the precision of the probe is. And there's actually sheets on these that tell you, okay, these probes will be precise to 0.2 of a degree or 0.02 of a degree. And so that's a really nice feature to know about when you're setting this decimal precision. Notice over here we're in a time-based sampling, and when we're doing calorimetry, what we want to do is we want to know a min and a max temperature. And if they're just shoving a temperature probe into a styrofoam cup full of water, they might miss that moment that we hit the maximum, or they might miss the minimum temperature. And so what I have here is I have a time-based setup. We're going to do 2 samples per second, and we can change that just by clicking on it. We have a 180-second duration, which is 3 minutes. If we're doing this calorimetry and dropping a metal slug into a sample of water, 3 minutes is probably long enough. And if you think about how many times they can do this sampling in class, typically my students will do like 3 different samples. They'll do one, get a fresh batch of water, let the slug heat up, and then do another, and make sure that they're looking at averages. And that's one of the things that I think is going to be really important in a moment that I'm going to talk about. So the 180-second duration. What happens now is they stick their temperature probe into water. I'm going to mock this up. And so the way I'm going to do it is we'll have to assume that we have water here. I'm sitting at my desk right now, but we have water. We're going to stick the temperature probe into the water, and I'm going to use my hand to warm this up. But you'll notice what's going to happen. I'm going to hit start, which is obvious, is the big green button. I hate to say obviously, but I know what my students do. They ask the question, what do I do? So you click the green button, and you notice we start sampling. And as this is sitting in water in the calorimeter, we should see something very similar. We're going to take the metal slug, we're going to drop it into the water. The energy from the slug is actually going to start to go into the water, and the temperature of the water is going to start to be measured, just like we're doing with my hand right now. And after they've ran that sample, they can hit stop once it starts to plateau off. And you'll notice we have a really nice graph. It zooms to that particular graph. Now, there's lots of fun data to do with this. We can look at rates of change, so we can look at tangents really quickly. I just spent a bunch of time with my students looking at tangents, change in temperature over change in time. And we were looking at which coffee cup was the best. We had a whole series of coffee cups, lined them up, and the kids all took their temperature probes, and they figured out that the styrofoam cup actually decays in energy, has a slope that is the least out of their all these little nice cups that they brought to class. Does each student have, Renee asked, does each student have their own probe? I have a set of data collection sleds in my classroom, so I have 12 of those, and I have enough temperature probes for each one. And so in my lab, I have a full setup that every 2 students can do this simultaneously. And with Navigator, which Mike talked about earlier, I can actually see all of them collecting this data simultaneously and be able to grab this set of data from them and share it. So as I look at this set of data, I want to know some information about this data, and so I can get things like mins and maxes. On the Nspire, when you're in a page, to operate some things on the page, we want to press a menu button. And so when I select menu, you'll notice that we have all these different options. But we really want to analyze this data. And the thing I really would like to know is I'd like to know the maximum and minimum temperature. So I'm really looking for the statistics of this curve. I'm not necessarily want to fit this curve. Now I could, but I really want to look at the statistics. So I select statistics, and here's my min and my max, 23 degrees and 28 degrees. So if this is water, I would want to know those mins and maxes so I can actually put them in. So as we move forward, we could actually do more samples. So if I wanted to do another sample, but I wanted to keep this one. And this is a crucial feature for kids to pay attention to because, and teachers, is if I hit this green button again, it will overwrite the set of data I currently have. So I need to click the check mark, and it actually saves this set of data, and you'll notice that this becomes run 2. If I want to go back to run 1, I can click on it. Here's my run 1, and it can appear for me. And so now I can show multiple runs simultaneously. Actually, as I get the second run, I can actually show the second run simultaneously. So if I run one more time, I must be holding it in the exact same spot. Pretty nice parallel there. All right, so stopping that one, you'll notice we have multiple runs showing. I can change that again to one run, both runs, and look at those different runs. Now, as I go through this, I can start asking questions. Okay, what was the minimum temperature? What was the maximum temperature? And I actually had the students do this, and so I figured out for the water as we were doing this, my minimum temperature that day was, I'm gonna make up one here, 20.0 degrees Celsius. Like that happens. And then notice down here we have maximum temperature was 26.93 degrees Celsius. So I'm just asking questions along the way so that it prompts the students to look back at their set of data and pull it forward. Okay. I also used what's called a notes page to put in some data that can be dynamic. And so I noticed I put in here, it says mass of H2O, and I'm going to put in 100 for the mass of H2O. Michael, it did not snow in Montana last week that I know of. Temperature minimum was 20 degrees. Temperature maximum. And notice when I put this in 6.93, it should automatically give me a delta T down here. Oops, I put in the wrong number. 26.93. And for some reason, my calculation is not temperature max minus temperature min. Something's going on with my calculation there. I must have typed in wrong. And so what the students can do is then calculate this information. So what I did in this class, because I knew enter on T min, okay, so there's my, oh, thank you. Thanks, Fred. Yeah, when you're doing this, you're not thinking ahead. All right, so what happened is, notice we get 6.93 as our min. What I did with my kids, though, is I sent them a document, and I'm going to scroll to the end of this. I sent them a document that says, give me the mass of your water, and then your change in temperature of your water. And then I sent it out to them as a quick poll. And you'll notice that Mike did this earlier, and what he did is he captured a whole variety of data he had 3 different students. And I'm going to show you a quick little clip of what happened in my class when we did this. This is a short video of my class as we started it. Notice we're on that same page. And what's going on as we go through this is I'm going to I hit the start poll at the top here, and you notice it says stop poll now. And as the students start to populate that, you'll notice at the bottom we have 1, 2, and the kids are starting to populate this spreadsheet for us. And once they submit, I'm going to jump ahead a little. You'll notice that the submissions are coming in. 12 out of 13 have submitted. I jump to my results, and here's my masses and my delta T's. Each one of the kids was allowed to change the amount of water that they happen to use, and you'll notice that the delta T's come up. And what's great about this set of data is as we start to look at it, I sent that as a table back to them to analyze this data. And immediately it set it into this particular format, which is a document. I turned around and sent that document back to the students. And now all my students have this set of data, and we got to talk about it. I had them plot it in a data and statistics. At the bottom, I selected the
and Todd, they really love it when they see these dots move on the screen. I don't know what it is about it, but the kids absolutely think it's amazing when they see all this data turn and move and become just organized.
It's like magic.
Yeah.
What happened is, if you'll notice, we have an outlier. In my class, I just call him a liar. No, so we started to talk about who put that point in, and what I was able to do with the whole class is we talked through who mishandled, basically misentered a piece of data. And so as we started to look at it, somebody put in 692 as opposed to 50. And we went in and typed in 50, and then we were able to quickly jump back to the data and look at it again. And you'll notice a really nice model here from this set of data that the students got. Even though they picked different volumes of water, that temperature change has a correlation. And so we were able to talk about that correlation and kind of had fun with it. So after we got that data, I came up and we started looking at, had them do mass times the delta T and times the specific heat of water, and we noticed that throughout these, we got 4.9 or 4.89 something all the way down. You'll notice all these different heats, and they're all very, very similar. And what we're able to do from this is now get an average, and the kids are actually able to get an average energy, pulling it back to calorimetry and saying, well, on average, our specific heat for copper should be this. And a lot of times our kids think that their one sample is enough to make a decision on. And I harp on them continuously saying, one time through does not make good science. And so by giving them this large amount of data from every student in the classroom and analyzing it as a group, we can actually look and say, well, you know what, taking everybody's data, how close is that to actual data? This is actually Chem 1, Stacy, that I do this one in. And I really actually start out fairly introductory with this. This is kind of at the beginning of calorimetry before we start doing chemicals in calorimetry. But it's doing specific heats with them. And so you'll notice that the document, after we pull that data back, we start looking at some other things. How many joules of energy are in the water? And we calculated that. And how many joules did the slug give off? And this is time to talk about directional energy. You know, if one gains it, the other one's got to give it up. Actually, Jeffrey just asked a great question. He said, you know what? He said, should we collaborate with math and science? Absolutely. I actually at one point taught my own, I taught a class where I taught the science and the math simultaneously. I had both topics that I needed to cover, and it was much, much better when you can teach them both. Or I've had years where I've collaborated with a math teacher. I got data when they needed it, and they did the math when I needed it. So it works amazingly well. Okay, so you'll notice how this document's laid out. Just to finish this off, what is the specific heat of the slug? The students would give this. Now, one of the things that somebody had asked in the pre-conference is, can I print this graph? And I'm going to show you one way that I do this frequently in my classroom. My students all use Google Docs, and they write up their labs in Google Docs. And so what I do is I can do a screen capture of everybody in class. And I actually have one handheld plugged to my computer right now. I don't have my Navigator up and running like Mike does. But if I wanted to pick this one student, and then let's see if I can do this. I want to capture from class the only person that's logged in. And what's going to happen is you'll notice the screen here. This particular screen is, you know, of just the screenshot or the opening screen. But maybe I want to grab a hold of this. So what I can do is I use the snippet tool, and I can go back to that. I'm sorry, I jumped to that. And what I do is I highlight it and capture it. While they're in lab, they're connected to me through the Navigator system. And then I open up a Google Doc in their folder, and they share their folders with me. And I just copy and paste that into a blank Google Doc, and then they're able to add that to their labs. You know, whether it's a graph, I'm just taking screenshots for them. Now, Mike, I think, is going to show you another way to do this as well. And I thought it was a good thing to address, because a lot of people are saying, well, how do I get this out to student labs? How do I get this as evidence for what the students have done? And so I think that's really important for people to understand, is that we can get this stuff out and into their lab reports.
Yep, definitely.
I think, Mike,
yeah,
I may hand you the ball.
All right.
And as I'm switching, as we're switching off again, if anybody has any questions, please throw them in the chat window. We'd love to answer them. Trying to give you the ball. I better stop sharing. There we go.
All right. Thanks, Todd. Appreciate it.
It's in your hands.
All right. Here we go. All right. So we have another activity we'd like to look at here. One that I've done in my classroom. One that I've worked with a couple other teachers and done as well. And the great thing about this activity is it can vary. I want to show you how to use the force probe today, and how you could use this probe in a variety of different ways. So I asked my student, and this actually, believe it or not, I did something like this with sixth graders even, but it can be taken all the way up to physics in high school. And what I asked my sixth graders was, how does mass affect the force of an object, and how it hits when rolling down a ramp? So let me show you. I have some pictures, actually, of how we set this up in school. Now, first thing you'll see is a picture of the force probe. And the force probe, if you look right, it's a little hard to see in the image right there, but there's a little rubber nub at the end of it. One thing that's great about the force probe is you could either have a hook attached to the end, or you can have a rubber nub attached to the end. And when something comes down and hits that rubber nub, it's going to measure the force. And with that, we can do a lot of things like measuring the impact something has as it's going down a ramp. And we can then take that force, and Todd sort of showed it a little bit earlier with the max and the min, and we can get the maximum force and determine how much force an object, hit the end of the ramp with. So there's also another setting on the force probe. It's towards the top up here. There's a 10 Newton setting and a 50 Newton setting. It's sort of like an on and off light switch to a degree. If you want more precise measurements, 10 newtons or less, you want to have that set to the 10 Newton setting. But if you're, rolling a 200-gram mass down an incline, you're going to want to set that to the 50 Newton setting, so you get that measurement. Now, what we ended up doing was we used these cars, and you can get these from any science supply store. And we were able, the reason why we chose these was we were able to put some weights and everything inside the middle of the car here. And we constructed a ramp. I have to give a lot of credit to some of the people I have at my school. They worked on in building these, and we had a class set of each of these ramps that we put together. The nifty thing about these ramps is we have a motion sensor that we could attach to the top here. So if you wanted to get the CDR2, so if you wanted to get the acceleration or the velocity, we Velcroed the CDR2 down to the top part here. And we hooked the force probe up to the bottom end on the right-hand side over here. And we had that car, which went right down. This is sort of like the wooden part of the base of a door that we hammered down onto the base here, and the car just sort of rolled right down this track until it hit the force probe. So what we had the students do is the ramp height could be adjusted between 10, 20, and 30 centimeters. We had our students keep the height at a constant 20 centimeter for all trials. Now, and we had the students manipulate the mass. Now, the car had an initial mass of around 60 grams. We had 50, 100, and 200 gram masses that could be placed in. The great thing about this is you could have the students measure a multitude of things. How does in changing the incline, the angle of the incline affect the overall force it hits with? How does the mass affect the force it hits with? All different types of things that the students could, in essence, measure. So before we begin, I have the students go through and answer a couple pre-lab questions. And as Todd showed you earlier, these could be sent out as quick polls, or they could just be answered within the document itself. Now, I actually already have
Hey, Mike.
Yeah.
Mike, I want to stop you for a second. One of your windows, either your chat or your participant window, is overlapping your document, and now we're getting kind of a scattered screen there, so we're not actually seeing your whole screen.
See that.
Hey, Mike, I think I know what happened. I think you're actually sharing your event window and not your desktop. Can you just do one quick thing for me, if you don't mind? Sorry to interrupt here.
Yeah.
Can you stop sharing your desktop for 1 second, Mike? And let's try one more time. Just share my desktop and don't share the event window. Let's see if that fixes it.
There we go.
Thanks.
Yeah, sorry about that, guys. Okay, so I already have a force probe plugged in here. And as Todd was mentioning earlier, we have the basic setup with the play button. We are going to conduct a time-based experiment, and we'll just keep the rate set up for 50 samples per second now. If I wanted the students to change the duration, all you have to do is click on duration, and I could change this to 5 seconds. It's not going to take longer than 5 seconds for the ball to roll down the ramp or car or whatever you choose to use to hit the force probe. And you'll notice that when I change, it's tough to see the way I'm holding the force probe, but right now I have the force probe facing up towards the ceiling, and I have a force of around 0.15 newtons. When I flip it, face it down, the force changes to around 0.35. What I want to do before the experiment is I want to zero that force probe out so I get a baseline 0 reading. To do that, all I have to do is click on the white box. And you'll notice on the bottom left-hand side, I have a 0 button, which I'm going to press. Now that's going to zero my probe out for me. Next, to collect data, I'm going to press the play button, and I'm just going to actually place this up against the bottom of the table. My navigator screen just closed out, guys, for some reason. give me one second.
Mike, as Mike
Yeah.
does this, as he gets focused on that, if you notice the screen that he actually has on his page right now, go ahead and get your thing going, Mike. But,
I am. It's loading.
You'll notice these files, these forensics files, as well as biology, chemistry, life science, or science activities, are all on education.ti.com. And many of the curriculum things that we already do are already waiting for you just to download. We've created those over the years, and TI has grabbed onto those and put them up on their site. And it's a great resource as you're starting to look at topic areas. I remember the last time I taught geometry, which I'm a chemist, but I also have a math degree. I went back and I looked through all the geometry topics, and I downloaded everything from geometry they had and paired it up with my curriculum that I happen to be teaching. Same thing with the science stuff is if you're teaching chemistry, looking for those files that you know you're going to teach, see what's there so that you don't have to recreate the wheel, or maybe it makes the wheel better. It's a great place to go look.
All right, I've got to open up the file here right now. I don't know what happened there, Todd. It sort of just closed out on me there for a moment. Let me get that file back open here, and we'll be golden. All right.
Yeah, Jeff.
So,
the geometry of chemistry, Jeff, is all three-dimensional, so it ups the ante a little bit in geometry in high school. Okay, you're on,
right.
Mike.
Yeah, I'm on here. All right. Sorry, I don't know what happened there, guys. All right. So I'm going to set this to 5 seconds here, and I'm just going to press the play button. And when I push down the force probe, you'll notice I get a little spike right here in my data. You'll notice that it is showing towards the negative 50 newtons right here. There is a way, if you wanted that to be a positive number because it hit the force probe, I could have went back into the settings and clicked on the box and clicked the reverse readings button. All right, now I'm going to do that experiment one more time. I'm going to press the play button. I hit it, and you'll notice now I'm actually in the positive reading right here. So you'll notice we're actually going north here towards 30 newtons. Todd shared this earlier with you guys to get the max. If I want to find the max total force that this hit with, I could hit menu, and then, of course, the analyze and the statistics. And that's going to give the max amount of force. This works out really good if you're designing a car bumper activity and you want to try to figure out which car bumper is going to work best. There's a couple really cool activities on the Science Nspired website that do utilize the force probe. Now, we did have a question earlier in when everyone submitted their questions, how could we pull data off and then share that data and actually print it? Now, Todd showed you a way earlier using Google Screenshot and actually capturing the screenshot and using Google Docs and sharing it that way. I want to show another way that you could share this data. So earlier, I completed this file and I saved it to the portfolio. Now you'll notice here this student CCC got a 67. This is the ramp physics activity that I just showed you. If I right-click on this, you'll notice I have a open for editing right here. So I just right-clicked on the one that was collected and I open for editing. What that's going to do, you'll notice here at the bottom of my screen, it says CCC Ramp Physics. This is that student's file that they worked on earlier. And it has all, you'll notice question 1.7 has been answered. And on page 1.9, they completed 3 different runs, as Todd showed you earlier, how you could complete 3 different runs. Now I can print this actual screen here, page 1.9. If I want to print this, I would go to File, and I can click Print. Now you'll notice that I have this screen right here, and I can change the page range. So if I want to print page 1.7 or let's see, what page is that data on? 1.9 to 1.10. I can have the data here, and I can have the data here. And then I can print this or even save it as a PDF. And then the student can have access to this actually printed right here. And they'll have all of their data ready to go.
Hey,
And
Mike,
yeah.
question here is, do those spikes represent when the ball hit?
Yeah, those spikes actually do represent when the ball actually did come into contact with the force probe. And it's really interesting too. You can change we're running a little bit of time, but you can change the x-axis to actually show the amount of time that it took for the ball to actually hit. And you can get a lot of different measurements from that as well.
By the way, that's called impulse. If
Yep.
you want to look that up.
And I actually think we're running a little bit out of time here. We're at 8:55. Mike, should I pass it back to you?
Sure, that's okay. And I think maybe Todd or Mike, if you can try and answer some of those questions that are still coming in, that would be great.
All right.
Thanks so much. So we are going to start wrapping things up tonight, especially if you're a new Navigator user, or maybe you haven't brought the Navigator out in a while. I wanted to show some resources that are available on our website, which is education.ti.com. There we go. And to find more resources, check out that professional development tab and then online learning. Once you're there, you can look at a few different things. I'd like to highlight the technology tutorials. And then we have a link here for the TI-Nspire Navigator System. So I can click on this link. It says Atomic Learning Tutorials. And what our friends over at Atomic Learning have done is they've created many short videos about how to do certain skills using the TI-Nspire Navigator. They've also created those skills for the software or the handhelds and also the app as well. So if you're looking for more information, this is a great free resource. We do have a few remaining upcoming webinars for the spring series. Those, again, are free and registration is open, so please feel free to take a look over those, and if you think those would be something that would be of interest to you or someone else, please feel free to register or pass along that information. The T-Cubed or TI summer workshops are open for registration. We have, I believe, over 70. We have over 70 workshops that are being offered this summer, and they really offer a few days of top-notch hands-on instruction. So it doesn't matter if you're using TI-Nspire technology, or maybe you're looking to learn more about PA-84, or you're a math teacher or a science teacher, or you're a science teacher who went and got a math degree. It doesn't matter what your background is. We have workshops that are available in different areas of content as well as different technologies. Each webinar, each week this spring, we are offering one lucky winner a free registration for a summer workshop, and this week's winner is Margaret DeBase. And so Margaret will be in touch with you probably the next couple of days to get a little more information from you. But congratulations, Margaret, on being this week's winner. If you like some of what you saw tonight from Todd or Mike, please feel free to continue the conversation. We're active on all major social media outlets. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link to the documents that were used tonight. I believe earlier Todd and Mike mentioned that you get those documents from the Science Nspired website. But if you wanted to have them right now, you could just click on that documents link and get all those documents that were used tonight. Also, I included like an important link in that documents folder. So if you're wondering whether maybe your Vernier technology is going to be compatible with your TI technology, there's a link in there that will address that as well. Thanks so much, Todd and Mike, for putting all the time together that you did to really go through a few awesome activities. I can't wait to use that track for the killer activity with my kids. I think they're absolutely going to love it. So thank you both so much for everything that you discussed tonight.
Thank you for letting us do it.
Yeah, thank you so much, Mike. And sorry, guys, about that little technical hiccup there for a moment. That's what I guess live performance does every so often.
No problem. We hope to see everyone back online next week. Thanks so much.